How do you make it as safe as today's commercial air transportation system? How do you assemble that whole thing and advance it to the FAA and ultimately validate and prove that it can be just as safe and that it's appropriate for commercial service? That's a now thing. That's not a 2030s or a 2040 thing. These systems are ready today. They've just been waiting for someone to kind of pick it up and take on that challenge.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 409. How close are we to seeing autonomous air taxis? For that question, we head to California to speak with Brian Yutko, CEO of Wisk Aero. Wisk Aero is an advanced air mobility company dedicated to delivering safe, everyday flight for everyone. Wisk's self-flying electric vertical takeoff and landing air taxis will make it possible for passengers to skip the traffic and get to their destination faster. Headquartered in Mountain View, California, with locations around the world, Wisk is an independent company backed by the Boeing Company and Kitty Hawk Corporation. With over a decade of experience and more than 1,600 test flights, Wisk is shaping the future of daily commutes and urban travel. Prior to joining Wisk, Brian served as Vice President and Chief Engineer for Sustainability and Future Mobility at Boeing, where he led a team that leveraged the company's technical expertise in sustainability technologies, as well as emerging advanced aerial mobility applications. He was the Chief Technologist for Boeing NeXt and sat on the board of directors for Wisk following its founding as a joint venture with Boeing. Prior to his roles at Boeing, Brian was the Senior Vice President of Programs and Vice President of Research and Technology at Aurora Flight Sciences, an industry leader in aviation autonomy and rapid prototyping. He was a research engineer in the International Center for Air Transportation at MIT, where he earned a PhD and Master's of Science in Aeronautics and Astronautics. He also earned a Bachelor of Science in Aerospace Engineering from Pennsylvania State University. In this edition of the Drone Radio Show, Brian talks about the progress that Wisk Aero is making to develop and deploy autonomous air taxis, including the results of a recent successful air taxi flight demonstration at Long Beach Airport. But before we hear from Brian, I want to stress that your support is the heartbeat of my podcast. Every episode is crafted with you in mind, and your generous donations ensure I can keep delivering the content you love. Whether it's the price of a coffee or a more substantial contribution, every bit helps to defray the cost of production. Donate today and be a vital part of the podcast's continued journey to greatness. And for a limited time, donate $100 or more and receive an official Drone Radio Show coffee mug. To donate, go to droneradioshow.com/donate. And if you can, please subscribe to the podcast on your favorite platform and leave a nice review and rating on iTunes. It really helps improve the podcast ranking among the many thousands of active podcasts today. So let's learn about the prospects of autonomous air taxis with Brian Yutko of Wisk Aero. Let's pick up the interview where I asked Brian to introduce himself.
I'm Brian Yutko. I'm the CEO of Wisk Aero, and we build autonomous electric aircraft, and we're based in Mountain View, California.
Brian, how long has Wisk Aero been manufacturing the aircraft?
Well, in various forms, the company's existed since about 2010 or so, when it was started by Larry Page and a few early pioneers in the electric VTOL industry. And the company, in its earlier forms, has achieved some of the industry firsts. The first electric VTOL flight and the first transition of an aircraft of this type from hovering flight to forward flight. But really, the company took its current form when Boeing and Kitty Hawk formed a joint venture in 2019. So the company is now through about 5 generations of aircraft. So the 5th generation aircraft we've been flying publicly recently. And what we're really working on with most of our team right now is building and certifying our Gen 6 aircraft, which is a 4-seat airplane that we are in the middle of a type certification program right now with the FAA.
What makes Wisk Aero different from other advanced aircraft mobility companies?
We don't have any flight controls on the aircraft. And I think there's a number of things that really differentiate the company and how we're approaching it. But from a product standpoint, it is an autonomous aircraft, and it's supervised from the ground by a human supervisor that's observing the operations of the aircraft and ensuring that they comply with the mission intent. And we can talk about what that person does, but there's no person on board the aircraft that actually controls it. So as far as we know, we're the first company that has conceived of a clean sheet commercial autonomous aircraft and applied for a type certification from the FAA, and is in the middle of working through that certification program with the FAA right now.
Now, it's designed to carry passengers, but will it also be used for cargo?
It's designed to carry passengers first and foremost, but we, of course, have variants of the aircraft where we've thought about carrying cargo. Like most aircraft, if you want them to carry passengers, you have to think about safety of life services and systems, so HVAC and things like that, that you need up front. And then the cargo version of that aircraft typically takes many of those systems out.
Have you received much skepticism or resistance for designing specifically for autonomy?
Oh, certainly. It's a very polarizing idea, I would say. And that's okay. We appreciate that. You may have heard this term, if you really want to do things that change the world, you have to be non-consensus and right. And so we're certainly non-consensus on this point, and we believe we're right. But of course, we just have to do the work to ultimately show that we can make this aircraft safe enough and certifiable. I'd say that there is a substantial community that sees what we're doing and appreciates the pioneering nature of it and appreciates that we've really started from first principles and did the system engineering work to architect an entire system that we think can be safe enough to fly people without an onboard crew for the first time. But of course, there are others who believe that there are other ways that you can get to that same end state. And that's part of the fun of it. So it's definitely a polarizing idea.
It's an interesting approach for sure. But truthfully, if the ultimate goal is to get to autonomous air taxis, it makes sense to go ahead and design for that from the get-go.
Yeah, and we think that it's important for 2 reasons. First is principally safety. Unfortunately, the small aircraft space, I'm a general aviation pilot myself, and the small aircraft space does not today enjoy the same safety levels as what we all experience in the large commercial aircraft space, which is just incredibly, remarkably safe. It's hard to even fathom the statistics for how safe today's commercial air transportation system is. But unfortunately, the general aviation space and helicopters are not nearly as safe as that. And so it's our position that we believe automation and autonomy can bring dramatic improvements in safety into this space, which, to be frank and very clear, you and I aren't going to put our families on board aircraft that we fly on, for everyday type of flights, unless it meets a similar safety outcome as what we experience in the rest of the air transportation system. So we think autonomy can get you there from a safety standpoint. And we're really excited about that. And then, of course, there is the benefits that we think will come from scaling. And, a lot of folks point out the additional revenue seat from not having an onboard crew member. And that's true. But principally where we see the value of autonomy is in making a very flexible network, a network that's very responsive to where the aircraft need to be and not having to solve the crew network at the same time as you're solving the aircraft network and then the passenger network. So it's a much more flexible transportation system.
Can you describe the aircraft, particularly the components that are designed with autonomy in mind?
The aircraft is a 4-seat airplane that flies. It's a battery electric VTOL airplane. that takes off like a helicopter. It flies like an airplane, lands like a helicopter. And so it flies less than 100 miles. It flies at general aviation aircraft speeds. So think like 120 knots or so during cruise. And it's got all kinds of, I think, incredibly interesting features as an aircraft designer about redundancy built into the system, and how the 12 motors work and how they're connected through the high voltage system into the batteries and all the other things. But I suppose I won't point those out here because you asked about what's interesting on the automation side of things. And so obviously, the aircraft has highly redundant avionics systems. And so we have redundant flight control systems that think about keeping the wings straight and level and flying waypoints, et cetera. That is done in the flight control system. We have a separate redundant mission management system, which you could think of that as executing many of the higher level functions in the aircraft. Think of detecting and avoiding another aircraft traffic as an example. It's just one example in the mission management system. And then it's very important to think about how do the aircraft systems actually extend well beyond the aircraft itself. So of course it carries sensors, and it uses those sensors to both detect, other traffic, but also to localize itself in the event of losing GPS as an example, or to navigate to intended, mission sites, vertiports we call them. And then of course the aircraft has to talk to the ground control station. It needs to talk to other participants in the air traffic system. And so there are C2 links. And then we actually have a supervisor who sits on the ground and oversees the operations of that entire system. So it's really important to not just think of the airplane itself and the computers that reside on it and the algorithms that reside on it and so on. But you really have to think, in order to do this at such a safe level, as I described before, you have to think about the system very holistically. So we've started from scratch and done that. The last thing I would point out is we do imagine that there's a role for what we call provider services for uncrewed systems, or PSUs in the vernacular. And so these are service providers, airspace service providers, basically, which would provide safety of life services that could be relied on for, navigation as an example, but from not directly from an ANSP, so not coming directly from the FAA in this example. And so we work with a company called SkyGrid right now. They are a company based in Austin, Texas, and they're developing a lot of those kind of airspace services.
You mentioned there's a supervisor on the ground. What's their role, and do they have the ability to jump in and control the aircraft if needed?
The way to think about what they do is to first start with how do they interact. And you might imagine that they have a joystick or something, and they're able to fly an aircraft in the same way that you might fly an aircraft if you're sitting on it. And that is not the operation. That's not the operating mode the supervisors on the ground have. They have a keyboard and a mouse. So it's important to start there and to imagine someone with a keyboard and a mouse. The kind of input that they can give is actually very high level input to the aircraft itself. So they can approve a mission. They can give the aircraft a vector. That's the lowest level of input that they could actually provide. Because in today's air traffic system, you always have to be able to take a vector from air traffic control. So the supervisor would actually speak to air traffic control and to be able to take a vector. But to a large extent, almost all of what they do is approve missions. And that means, a complete mission intent from end to end. And they're supervising multiple aircraft doing that.
In October, Wisk became the first eVTOL air taxi company to fly in the greater Los Angeles area. The company conducted test flights of the aircraft at the Long Beach airport. Tell us about the demonstration. What did Wisk Aero do?
We were really excited to be flying at the Long Beach airport. We flew in a very public forum at the 100th anniversary of the Long Beach airport at what was called the Festival of Flights. And what we had done there was actually, in an active airport, rolled out to the runway and had to hold for landing traffic. So there were literally Southwest airplanes landing at the airport, to give you a sense. We took off, we flew up and down the runway a few times, executing full transitions from hoverborne flight to wingborne flight on the Gen 5 airplane.
What was the crowd like?
I can't quite remember exactly how many folks, maybe around 10,000 folks in the crowd at that time. But importantly for us, it was really about engaging with the local community and understanding what it really means to deploy autonomous systems to active airspaces and airports with a team and to be able to fit into the airspace and to really understand what it means to operate in an environment away from your test site. So we actually ended up flying a number of times in the lead up to the Festival of Flight early in the morning. And it was interesting that no one really noticed because we're not a loud airplane. We're a very quiet airplane. And we were able to seamlessly fit into the airspace operations there. So it was great for our team to just really learn what it means to interact in that kind of environment and to deploy into that kind of an environment with a serious autonomous system. And the other part was really for much of our team to interact with the community and to interact with the mayor of Long Beach, who's just an incredibly innovative thinker about the future of Long Beach as a community and how these kinds of new air transportation systems can fit in and can benefit the community. And fundamentally, what we heard from everybody was that they were very excited about this kind of a system because it represented a transportation system that was safe, clean, and quiet. And we heard over and over and over again from the community that what people wanted was something that was safe, that it was clean, it had zero source emissions, it's battery electric, and it's got to be quiet in order to fit into the community.
What did Wisk learn from the demonstration?
Principally, what we learned were in those two dimensions of what it takes to really deploy a team and an autonomous system, because keep in mind, it's not just the airplane, it's also all the systems that are associated with the airplane and how you speak to it and how you interact in the airspace and how you are a good citizen around an active airport and keep your operational efficiency high and you're non-disruptive and all those things. So lessons around deploying is kind of bucket number one. And bucket number two are the ways that we interfaced with the community and what we learned with the community and how really having a transportation system that's safe, clean, and quiet, those are the three things that you've got to do in order to have the right to start to stand up transportation services in a city. And we were very pleased with how excited folks were to access these kinds of systems and how much potential they saw in what we were building. And we're really excited to just build on that momentum.
From a city planning perspective, urban air mobility creates a lot of interesting city design alternatives and mobility options. For me, it's great to see air taxis moving to a point where they might soon be operational.
Yeah, it was really cool. And especially from the mayor's perspective and from the city council and many of the other folks that were there. Safe, clean, and quiet, of course, but also, how do you make these systems so that they're accessible to as many members of the community as possible so that they can save time too, so that everybody can save time. And so it's really interesting to think about, how can you make the systems as broadly accessible as possible while still meeting the threshold of being safe, clean, and quiet.
As the system is developed, will Wisk Aero be involved in helping communities figure out where vertiports should be located or how they should be used? I guess what I'm asking is, are you primarily a manufacturer of the systems, or will you be assisting with the service planning, deployment, or operation?
We'll actually be both the manufacturer and the operator initially. And what that means is that we actually have to do a lot of the pioneering work that you're talking about there of working with communities and doing route planning and doing vertiport planning, infrastructure planning. And so we have a team that actually does that. We are working in a number of communities right now where we are starting to evaluate early routes and what the infrastructure requirements would be and where might we start testing, both with our Gen 6 aircraft and with what we call surrogates. And surrogates really mean helicopters that right now we've effectively retrofitted with our autonomy system.
We hear a lot about AI these days. Does artificial intelligence have a part in Wisk Aero's autonomous system?
We typically try to keep the software in our aircraft as explainable as possible for certification purposes. So typically we use what in the vernacular is now called, formal methods and ways that you can really look at the code and verify exactly what it's going to do and only do that. And so it's a long way of saying we don't typically use a lot of machine learning and there's certainly none of the, generative AI topics that you're talking about there in the aircraft itself and in the algorithms that ultimately will be certified, because there's just too much of a leap for us to get there for FAA certification. And frankly, we can achieve the functions that we need to without that. Now, that being said, how those new technologies will affect every business will affect us as well. So even if we're not running some of the more complex algorithms in our onboard computers on day one, they certainly affect how we do our work in the same way that there's, tremendous efficiency benefits from having co-pilots, while you're writing software that are auto-generating software for you and doing all kinds of things. So I think we are just at the beginning of an incredible moment for all those technologies to impact our businesses. But at least for now, we believe we could do what we need with very explainable software. And that means that we're avoiding some of the more exotic and complex algorithms that are in things like generative AI.
So what's on the horizon for Wisk Aero?
We believe we can, get the aircraft certified and start commercial service this decade. And so that's probably the first anchor point that folks are always wondering, is this something for 2050? And it's this decade. We're building Gen 6 right now and test a lot of the subsystems. And we'll fly Gen 6 next year for the first time is our target goal. But of course, we'll only fly when it's safe. And so generally, we're on a path for flying next year. And, and then we're in the middle of a type certification program. So, these systems only carry commercial passengers and cargo when they're ready and when they're certified to be ready by the FAA. So we think we can get it done this decade. But between next year when we first fly Gen 6 and the end of the decade, we have a long road of testing and validation and really proving things out with the FAA.
On a personal note, what excites you about leading Wisk Aero at this time?
Well, it's just such an amazing team. I mean, the team here is it's just an incredibly pioneering, technically amazing team. I can go on and on about how great the engineering team is and testing teams and so on. But even, the non-engineering teams are amazing as well. I mean, you've just got a mission-oriented, mission-driven organization that's all in on one goal. And there's something really special about a company that has one mission and everyone's completely aligned to it and everyone is just exceptional at what they do. So I feel privileged and lucky every day to be able to learn from so many people and to be, working on a mission that I think is so good for the world. I think advancing technologies that are zero emissions are good and noble. And certainly we're, in our battery electric airplane space, we're not going to solve all the world's aviation sustainability challenges, but we're doing our part to advance very serious technologies that will do that. And I also believe deeply that automation will advance the safety frontier. And so that to me, that's a noble mission with a great team and everybody's completely mission oriented, focused on that one thing. So I can't imagine a better circumstance.
Is there anything that we missed that we should talk about?
I guess one thing I would emphasize, and this goes back to the question you're asking about, is our approach a controversial approach or one that folks agree and disagree with, et cetera? I think one of the things that we feel real conviction about is that the technologies that can enable the first, FAA certified passenger carrying autonomous aircraft, that these technologies are ready and they're waiting for someone to start from scratch and to piece together a whole system from the ground up with real thought around how do you make it as safe as today's commercial air transportation system? How do you assemble that whole thing and advance it to the FAA and ultimately validate and prove that it can be just as safe and that it's appropriate for commercial service? That's a now thing. That's not a 2030s or a 2040 thing. These systems are ready today they've just been waiting for someone to kind of pick it up and take on that challenge. And so that's why we're doing it. And so I think it's just something that we feel real conviction about, the readiness. We have a deep responsibility to actually deliver on what I just said, to actually be able to make a system that does what I just said. But we feel real conviction that we can, and that this is a subject for now. And certainly if you're sitting in the United States, if you prefer that the United States leads on these subjects globally, then we got to get the move on. And we're really happy to be, picking up that mantle.
And for my final question, Brian, what message would you like to leave regarding the future of advanced air mobility?
I think one thing I've come to appreciate is just both the difficulty and the nobleness of building stuff. It is so difficult to create something and to get the resources and the team and the ability to see a project through and to be certified and to wrap a business model around it and all these things. That is such a noble and difficult journey that now I universally just support people that really are in the trenches trying to build something meaningful. And given where I think technology is and how advanced so many individual technologies have become and how they're starting to collide in these very interesting ways and enable all kinds of new, incredible products, I think the most important thing, if I were to leave one message for people listening to this and wherever they are, is to find their way into a team or a company that is building something that you believe in. There's almost no more noble thing that you can do. It's really difficult, but it's really worthwhile. And the world needs more people building more great things. And so I hope more people join that journey.
That's it for episode 409 of the Drone Radio Show. I hope you enjoyed hearing from Brian Yutko of Wisk Aero. I want to thank Brian for taking the time to speak with me. If you want to learn more about Wisk Aero or want to connect with Brian, check out the webpage at wisk.aero. If you like the Drone Radio Show, then please subscribe and share. Write a glowing review on iTunes. And if you're able, donate to keep the podcast going. Go to droneradioshow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Goers.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.